This is for Year 12 Special. It's the continuation of question 2 in the TSSM Exam 2 2018 question. Okay, G, the function, and this is a function that can be multiplied on all of the complex numbers when applied to Z1, Z2, Z3, Z4 and Z5 will turn each of them into the circle in part E. So it started out as a circle with radius 2 centered at 0, 0, and it ended up in part E as a circle that was centered at root 5 plus 1 and had a radius of root 5 plus 1. Since we're working in complex numbers, Q will be the movement in the real field, so Q will tell me moving sideways if Q is a real number. So Q has to, so the circle was centered at 0 and it ended up being centered at root 5 plus 5, so Q equals root 5 plus 1. And the circle had a radius of 2, and then after it's being multiplied by P, the dilation has turned to a radius of root 5 plus 1. So P has to equal, divide by 2, so therefore that would give you a radius of 1, and times by root 5 plus 1. So that's what P and Q is going to be. Looking at H, if I have a cubic polynomial with real coefficients, therefore A, B, C and D are going to be real, and we have Z1, Z2 and Z5. Z1 is 2, so it's going to be Z minus 2. Z2 is going to be Z minus 2 chis 2 pi on 5, and Z5 is going to be 2Z minus 2 chis of minus 2 pi on 5, and I wish to expand that out. Now I believe there's a little typo, they have to be Z's because we have roots with complex numbers. So I might use my calculator to do that, and I might use X over on my calculator. So I've got X minus 2 is the first one because it's Z1. I've got X minus 2 shift equals 2 pi and 5. And I've also got, I pick all that up and make that 4 minus 2 pi and 5. So, which is what Z5 is. See, expand, there are no i's, so they're all real roots. So I could write that out as being x to the power of 3 plus, z to the power of 3 plus z to the power of 2, and I will have minus 1 minus root 5 plus, according to z, etc, etc, etc. And lastly, that answer goes up there. And lastly, is there a cubic polynomial of real coefficients where Z2, Z3 and Z4 are the roots? Well, Z2 is 2 chis 2 pi on 5, and that's Z minus. Z3 is Z minus 2 chis of 4 pi on 5, and Z4 is Z minus 2 chis minus 4 pi on 5. Well, these two multiplied would give you real coefficients, but this one here doesn't have a complex conjugate, so therefore no, it isn't, because you need complex conjugates, and since we only have 3, I have complex conjugates on 2 of the roots but not the third one. So therefore the coefficients cannot be real.